All right, well, good morning, class. Welcome to our first seminar.
Good morning, Dr. DeBoer.
Good morning, Dr. Hathaway. Got a few more seats today than we do normally. I guess the weather is keeping people away, or they're interested in modifying their food plan or something. Yes, so, but good to see all of you that are here today. Glad you made it. I have to announce that next week we do not have a seminar because of Mission Emphasis Week. And the week after next week we have a seminar, but it's going to be in a different location. We're going to be in Heath Hardwick, 101, 2 weeks from today, because of scheduling conflicts with this room for some reason. And after that we'll be back. Right? Yeah, got that on your calendar? Outlook or Google Calendar. Get in there quick so you don't forget these. All right, today we're going to talk about real applications of chemistry in the real world. Things that happen all the time with respect to prescription drugs, non-prescription drugs, and things like that. And a real company that's working right here in Longview, Texas, growing and expanding. And we have representing that company today, Greg Yellick, okay, who's an Ohio State type guy.
Alum, yes.
Yeah.
Go Bucks.
Yep. So he can tell you about his experience in chemistry, where he got his degrees, and how he became this forensic chemist, and is now managing this quality toxicology lab that's here in Longview. Okay. And we have had students working at this lab before, both as interns and as paid employees. So it's quite possible that in a few years from now you may be working at this place with either biology or in chemistry and get a bachelor's degree, and maybe you want to get some work experience before going on to a graduate school or something like that. So this is an important talk for you, because it might mean money for you in a couple of years, a job, okay? And also it's important because it tells you how the world runs with respect to drugs and medication and things like that. So let's give Greg Yellick a warm welcome.
Well, thank you. Thank you, Dr. DeBoer, for inviting me. Appreciate that. Thank you, LeTourneau University. There are some things I want to talk about with you guys today to let you know essentially how we're using instrumentation in chemistry these days to solve real-world problems. I did get my bachelor's degree at Ohio State University. Went on to become a private investigator. Thought I was going to become a police detective, but realized that I might be too nice to be a police officer, and that's kind of what's required to become a police detective. So while on a stakeout, I had a lot of time to think and thought, you know what, I'm going to go back to school and become a forensic scientist instead. So I went back to school, took quite a bit of prerequisites to get a Master's of Science in Forensic Science from the University of Central Oklahoma, which is a growing forensic science program in Edmond, Oklahoma, north of Oklahoma City. After there, I made some contacts. I interned at DPS, the main lab, Department of Public Safety in Austin, Texas, in their trace evidence section, and then got a job with some connections to San Antonio in the Bexar County Medical Examiner's Office. So I worked there for 8 years in their postmortem toxicology section. We did postmortem tox as well as human performance, so any DUIs that you might have seen coming from that area of the state would have been done out of our office. But there's this growing field right now, and especially for civil servants who maybe may not be making that much money, but have a lot of knowledge in terms of analyzing for drugs and toxins and poisons. And that is what we call pain management and compliance toxicology. So I left the county and joined a laboratory, Quality Toxicology, which now has a lab here in Longview, and we're starting a lab in San Antonio. So I kind of want to expose you all a little bit to how toxicology is relevant to what we're doing in the world today. But very, very briefly, how many biology majors in here? Okay, and chemistry? Okay, forensic science specifically? No? And then physics, engineering? The rest of y'all. Awesome. Okay. Well, you guys might be the ones that are making some of this instrumentation even better in the future, because what we're going to talk about later on in the presentation applies specifically to development of techniques of identifying drugs. So, and that requires physicists, and engineers. Well, prescription drug abuse is a problem. We have a lot of people who die from prescription drug abuse. Some of the statistics here, they do these studies frequently. These studies are from 2007 and 2012, but opioid prescription deaths, these are codeine, hydrocodone, oxycodone, are responsible for more deaths now than cocaine and heroin together. Okay? That's a big deal. And in large part, it's because of accessibility. These are the things that you can get maybe out of your parents' medicine cabinet. Or these are the kinds of things you can get if you go to the doctor and say, my leg hurts. So there is great access in terms of the legal drug that is causing people to overdose and die. We also see that we see more deaths than all illicit drugs. So we're also seeing more deaths than traffic accidents in some places. Travis County, TCMEO, is that case. We're also seeing where people who are on chronic opiate therapy, people who've been complaining about chronic pain for a long time, upwards to a third, almost 50% of them are having non-compliant urine test results, which means there's something in their test results. They're not either taking what they're supposed to, or they're taking something, or they're not taking something they're supposed to, or taking something they're not supposed to. So that could be illegal, could be a regular prescription that maybe is through another doctor they don't want your doctor to know about. But essentially, this growing problem is that people have learned that we can get our kicks from going into the doctor's office. Okay? And this is just going to get bigger because as the Affordable Care Act has more people on the insurance rolls, more people are going to be taking prescription drugs, and so more people are going to have access and potentially get caught in a path of addiction that leads to more problems. So, because of this, the DEA and other federal governments have recognized that there is a need to test. And so, insurance companies will reimburse for these types of tests to find out exactly what's in the urine. No longer can you just rely on the cup alone. So, how many of y'all have peed in a cup before? Okay. So they have little strips on some of these cups now that are supposed to give you a presumptive positive for what's in there. Well, presumptive positive, I wouldn't want to have my job decided on a presumptive positive. If I'm going to lose my job or not, I'm going to want a confirmation. And so one thing that is being reimbursed by insurance companies now to make sure that doctors aren't firing their patients for the wrong reasons is this confirmation. So with a growing number of prescriptions and government support and money, reimbursements, this has been a big growing field. Also, we sell, the idea is to the doctor, look, you can keep your medical license safe if you're monitoring your patients. If you can justify your treatment plan, we want you to do this testing. You can show this to the medical board that, look, I am monitoring my patients to keep yourself from being called the pill mill. Because there are pill mills out there. There are doctors that will prescribe opiates, and I've seen them. You're looking at 4 different prescriptions for 4 different opiates in the same person's urine. This person should be dead. But they're not. They're showing up for refills. Some other reasons to test and confirm, again, unrecognized drug use problems, whether it be illegal or legal. Drug diversion. There are 60-year-old grandmothers who will get hydrocodone for 30 days, a prescription, and come back in 2 weeks and say, I need another prescription. You test their urine, there is no hydrocodone in this person's urine, but it's supplementing their income. And so we see this drug diversion also. But it's your kids, it's your neighbors who are purchasing these from this grandma. So from a doctor's standpoint, yes, a clinic is going to want to have a risk management plan that's going to say, hey, I am monitoring my patients. And that last one, accurate results, applies to all of us. If we're going to have a pre-employment drug screen, you want to have accurate, confirmed results. So there are 4 major subsections of forensic toxicology. Postmortem forensic toxicology, that's dead people. And we have a number of different sample types that we can get from dead people, including the juice from the eyeball. Inside the eye, there's the vitreous humor. It's very sterile. It's a great place to find drugs. Human performance toxicology. So this is, maybe you do a mandatory blood draw because you refuse to blow in the breathalyzer. Well, now, not only do we have your alcohol concentration, but now we know what drugs you're on. Okay? So you have human performance toxicology. Workplace drug testing. This also incorporates the sports world, looking for steroids, very large molecules. And this last one is kind of the growing trend these days, is this drug compliance toxicology, which is what I've been talking about today. So I'm going to go through a couple of the drug classes here for what we test for, in case you didn't know about these drug classes. But the most commonly abused drugs in our world today, of course, alcohol at the very top, ethanol, is the #1 abused. And it also happens to be the #1 drug found in sexual assault cases on campus. It's alcohol. It's not Rohypnol and GHB, these date rape drugs. That's the media hype. It's really alcohol that causes more people to lose their inhibitions or inability to protect themselves. But we also see marijuana, cocaine, methamphetamine, heroin, and then prescription drugs. So when I'm looking at tox reports coming in from people who died in the medical examiner's office, these are the ones that we commonly see in cases of abuse. But prescription drugs, as I said, is a big abuse problem, and these top 5 here are the big ones that we see. Hydrocodone, oxycodone, carisoprodol, alprazolam, and morphine. Those are the big ones. You may know them by generic names because we see commercials on TV, and as we go through some of these drug classes, you'll see some of these trade names. But there is also a long list of these that we see on a daily basis. This one, there are some drug user forums that I visit to keep on tabs on what kids are using these days, and adults. I don't mean kids, but people in general. Quetiapine, this is an antipsychotic, but they've managed to find a way to use it as an abusable drug. Haven't quite figured that one out yet. That I saw just the other day. But as students, these last 2 here, amphetamine and methylphenidate, are huge as study drugs, okay? Where you go in and you feign that you have attention deficit disorder. It's a series of questions that they ask to diagnose attention deficit disorder. You get your Adderall prescription, and now you've got something that's going to keep you up for 8 to 12 hours or more. So this is another thing that we see in colleges these days. So all the drugs that are on the market these days and those that are in the black market fit somewhere into a schedule. Back in the 60s, they developed these 5 schedules to try to incorporate drugs along these 6 different questions. Was there a potential for abuse? Was there a chance for physical addiction or psychological dependence? Did it involve injecting with needles, which makes it a risk to public health, spreading disease? So they scheduled all these drugs to make hopefully the most dangerous in Schedule 1 and the least dangerous in Schedule 4 and 5. Problem is, Schedule 4 and 5 has a lot of the prescription drugs that are getting people addicted, probably, as we saw earlier, and killing more people than the ones in Schedule 1. Okay? So, but I kind of wanted you to understand how we got to this point of how we decide things are illegal. So the big one these days, prescribed more than any other drug, are opiates and opioids. These are meant to depress the central nervous system. Relieve pain is the main job. But when people die from opiate overdoses, It's large part due to the fact that their body can't circulate blood anymore, and their breathing gets so slow that there's not the oxygen getting to the brain. We call it central nervous system depression. Right, and these are addictive. You can start with a seemingly innocuous dose and end up an addict and somebody who. So I would urge caution when you're using opiates. You may be given hydrocodone. It's very commonly prescribed these days, but that is definitely one of those drugs that can get you into an opiate addiction. So the mechanism of action here, binding to opiate receptors, inhibition of pain pathways, making it good for analgesia. So if you were wondering about what some of those drugs were earlier, maybe you know the trade names instead. Those are some of the trade names here. Vicodin, we've all heard of Vicodin, right? Okay. OxyContin, that's the same thing as oxycodone. Chemists, toxicologists, forensic scientists recognize the generic name because this is what's going to be identified in our databases. When we buy standards from drug standard companies, we don't buy Dilaudid. We buy hydromorphone, okay? When we identify something, we don't identify Dilaudid, we identify hydromorphone. Up at the top, though, is an interesting one, heroin. Heroin injected into the bloodstream, or it can be, it's most often injected into the bloodstream. Some people will also snort it. But the idea here is we want to get it into the bloodstream. It is quickly converted into a metabolite called 6-MAM, 6-monoacetyl morphine. Okay, so it gets deacetylated. It gets deacetylated again to become morphine, which is why the whole reason for taking heroin in the first place is to get to that, essentially that metabolite at the very end being morphine, being the active drug. But what if you go into the doctor's office, you give your urine test, you're supposed to be on morphine, okay, and the doctor's wondering, well, maybe you're a heroin addict. Well, one of the things that they do to separate heroin addicts from, or recognizing heroin addiction versus somebody who's taking their prescription that they should be taking, is the presence of that metabolite there. So toxicologists not only look for the target drugs, but they look for the metabolites to confirm that somebody is actually consuming these. Because we have people that will take a little bit of hydrocodone powder from their pill and sprinkle that into their cup when they're supposed to be relieving a sample. Okay? You go to look at the cup, the little test strips say positive for opiates. Oh, well, you're compliant. Send it to the confirmation lab, and we're like, oh, where's the metabolite for hydrocodone? So one of the things that we do for the doctor's offices also is to try to circumvent this adulteration that occurs. People are trying to get really smart about this. Even like oxycodone, and oxycodone's metabolite is oxymorphone. Oxymorphone is also a prescribed drug. So we have some people that are sprinkling oxycodone and oxymorphone into their urine to try to circumvent the process at the confirmation lab. Well, we've got metabolites of oxycodone and other metabolites of oxymorphone that we can look for also. So a good confirmation lab should be able to tell you what's going on. By the way, if you happen to have, this wouldn't be on Laterno campus, but if you see little balloons laying around, little tips of balloons, that's a good sign you've got a heroin problem in your neighborhood. These are the powders wrapped up into little balloons and handed off easily this way. So that's what's being shown at the bottom. By the way, if you have questions, ask me. I would not have gotten where I am today without asking questions. Okay, lots of. Yes?
So what did you say about those little balloons? Like, is that what they put it in?
The heroin, yes. If you're buying heroin on the streets, in the big cities, they will package them up in little tips of kind of like balloons. They'll tie them off. You might have a handful of 5 that you can hand off easily. Heaven forbid they try to swallow them and hide them from the police because this stuff leaks and you will die. So, okay. So another class of drugs that's important to monitor for are the behavioral drugs. What they're finding now is that opiates in conjunction with antidepressants are actually having better pain relieving effects. thus reducing the level of opiates necessary to receive pain relief. So typically these are prescribed. These are not being abused, but then I mentioned quetiapine there, number 2. We're stabilizing our mood. We're feeling better about ourselves. And as I said, some of the off-label uses are for chronic pain. So we're increasing serotonin and norepinephrine in the central nervous system here with these drugs, and downregulating other receptors that might be in the system. 3 generations of antidepressants. We got the tricyclic antidepressants, which is this nice structure here at the top, is amitriptyline. What they've done, these tricyclics, there's several of them, but they've essentially learned by changing different functional groups on the tricyclic structure, they can have different functions. Some people will accept and respond better to these drugs than others. But the 2nd and 3rd generation antidepressants are starting to take non-tricyclic structures. In large part, they're trying to get away from some of the side effects like sexual dysfunction and some of the other problems with dependence, like the body's system gets dependent on having these levels of serotonin and norepinephrine. So they're trying to make more effective antidepressants that don't make people sleepy and such. So there's a lot of drug development going on that has to do with figuring out how these drugs work in receptors. Benzodiazepines, another big class of drugs that are both being abused and prescribed. Sedation and anti-anxiety. The big one that everybody must have probably has heard of is that first one up there, Xanax. Heard of Xanax, otherwise known as alprazolam. So all of these AMs, ending in AM, came from a central structure which is chlordiazepoxide right up here at the top. And again, what they learned is as they stuck different functional groups onto this drug, keeping the core structure, it could provide different characteristics. So we have a number of them here. Some of them are better for sleep than others. Valium is probably another one you guys have heard of. But there's 2 on the streets these days, phenazepam, which you get off the internet, which comes from Russia, and etizolam, which is being used more in Canada and UK, but are available on the internet, so we have to be able to see them in a compliance laboratory. Okay, must be good stuff. Fort Worth and Dallas, we do see this phenazepam, and it's even killed some people. Good old stimulants. How many Breaking Bad fans out here? Okay, well, just a couple. Breaking Bad, high school chemistry teacher comes down with cancer, has set aside no money for his family once he dies, so he starts making methamphetamine to basically leave his family something after he dies. It's a great series. But crystal meth is what he makes, and he ends up making it very good, better than anybody else can, and it kind of plays into the story. But essentially what we have here is a class of drugs. It's not just crystal meth. We also have cocaine and some of the designer drugs like MDMA, which is essentially changing some of the functional groups, designing a drug based on the structure of amphetamine or methamphetamine. But also, as I mentioned earlier, in this stimulant category is Adderall and Ritalin, which people are abusing these days. It's an upper. Keeps you up. Muscle relaxants. Okay, pain relief, treatment of muscle spasms, management of anxiety disorder is some of that last one is kind of an off-label use. I have a cross up there to remind me to tell you about the Holy Trinity. There is a cocktail of drugs right now that doctors, they don't know why they're being asked for these 3 drugs together, but people are coming in with these symptoms that are meant to elicit this particular cocktail of drugs. And it's hydrocodone, carisoprodol, soma, and alprazolam. Together give you the effects of heroin without the injection of the needle. So we're telling our doctors, hey, look, if you're seeing we'll ask them, have you seen these 3 drugs being prescribed commonly? It's like, oh yeah, these are the ones we always prescribe. Well, you may have a drug problem coming into your office. And I also note there for cyclobenzaprine, another common muscle relaxant these days, but it's got a tricyclic structure, which will trip a cup for the tricyclic antidepressants. We have something called cross-reactivity, and I'll talk a little bit about that later. Non-benzodiazepine hypnotics. So these are what we call the Z drugs. These drugs are helping people go to sleep. You've seen them on the television, Ambien, Lunesta, and Sonata. Mr. Walrus here is actually speaking the truth. Zolpidem, Ambien, is known for some very interesting things. Sleep eating, sleep walking, sleep driving, sleep sex. Things that are on the warning label. If you read the box, people will roll over, have sex with their spouse, and then not remember it the next morning, or drive down the street. I was involved with one case where we had an accident where somebody was killed. Driving down the street, the person did not remember. Had another case where somebody molested one of their cousins and was under the influence of Zolpidem, and this was a big back and forth to say, hey, this is a big deal. We can't have people just being sexually provocative in their sleep. So this has to be taken with a big warning message that these types of conditions, like watching for extra weight gain that you can't explain. I mean, that's kind of how they figured out this was even occurring. People were emptying out their fridges in the middle of the night, or having a lot of weight gain and not being able to explain it. Okay, so some other drugs that we do test for, and again, all these drugs that I'm talking about are some of the big ones, the more important ones. Gabapentin is one that we're seeing a lot of these days, and pregabalin, Neurontin, and Lyrica. You see those commercials on television. Gabapentin has a similar shape to one of the neurotransmitters, GABA, in our body. Problem is that, well, it's not a problem, but we found that there's a lot of off-label uses for it now, and people are being treated for addiction. At the same time, we're finding people who will take gabapentin together with 4 Monster drinks, the little ones in the can, and they experience the effects of cocaine, or like cocaine. And it's one of these drugs that the cups don't test for. So if you've got people abusing it, your cup isn't going to answer that question. Let's see, primidone for seizures, and ketamine. Ketamine's starting to come back around, also known as Special K. Started off as a horse tranquilizer, and veterinarian clinics started getting broken into, and they're cabinet rated, and this ketamine being taken. But it's also being recognized as having medical uses these days. Ketamine's being used to stabilize the brain for people who've had traumatic brain injury, especially in children when they come into the emergency room. So, still a relevant drug. And just a couple other interesting illicit drugs that we monitor for. Again, not typically prescribed, but I think you are going to see more marijuana being prescribed across the United States. This is not... when I go to pain conferences, one of the interesting things you hear about marijuana that's not talked about in the news is that all the pain-relieving effects, all the anti-seizure effects, all the appetite-stimulating effects does not come from the psychoactive compound. You can grow marijuana without THC. You can grow marijuana without THC that gets you high and still be able to treat people with these cannabinoids. In fact, humans have cannabinoids that are flowing through their body endogenously as we speak. For you biology majors out there, if you look in your textbook, we have what's called endocannabinoids. We have endocannabinoid receptors. So one of the things you're going to start to see in the next couple of years is probably the pharmaceutical industry getting into the role of identifying what these compounds are that are not getting people high, but having these health effects. So rather than getting hung up on, getting stoned all day, we need to start looking at some of these compounds that do have use in treating these symptoms. PCP, big in Fort Worth. We're seeing a lot of that. They call it wet, where you take a cigarette and you dip it into PCP and then you smoke it. Bath salts. How many of y'all heard of this term, bath salts? Right. These are compounds being created. Well, actually, I got a picture down here just to talk about it. In northern Africa, there is a plant called the khat plant, and populations will take 2-3 hours out of their day, kind of like a siesta, to chew these leaves. They get around, they talk, they socialize, and essentially make it incorporated into their culture. This would include Somalia, Kenya, some of those northern African countries. Well, some smart chemists in China figured out that if we can add some functional groups, we now have a very potent psychedelic. And so that's where this term bath salts came from. It has nothing to do with bath salts. You'd be blowing your money if you threw it in your bath. But it's meant to circumvent this process of FDA saying it can't be for human consumption. So the head shops will sell it as not for human consumption on the label, with all knowing that that's exactly what it's for. The problem is that these drugs have never been tested on guinea pigs. There's no quality control going on here. So a lot of people have been sent to mental wards and dying and doing crazy things because this is not a developed drug. This is, well, let's see how much fun we can have with chemistry. Okay? So keep that in mind as you hear about these. But I think it's interesting that it does have a natural source. Yes?
So you said it's a leaf that you chew on?
Well, the cathinone is, this khat plant is a leaf that gets chewed on. But when you start doing funky things to it, you have the ability essentially to create a psychedelic that makes you hallucinate. Synthetic cannabinoids. Have you heard about K2 and spice? It's been apparently a big problem here in Longview, actually. Lakeport seems to sell a lot of it. This is also dangerous. This was designed to be, well, it started off as a dissertation paper at Syracuse University by a gentleman by the name of John W. Huffman. That's why we call him JWH 18, JWH 250. They were meant to act on these endocannabinoid receptors to stimulate appetite in cancer patients and relieve pain in cancer patients. But someone the Chinese got a hold of his recipes and started making these, knowing, well, hey, let's see what else we can do with these cannabinoid receptors. So they started coming up with the various leafy materials that they would then spray with these compounds. Now, this is THC at the top here, and you'll see this long alkyl chain here. This is something that they're trying to focus in on, trying to make that receptor do things that it otherwise wasn't designed to do. So there are hundreds, and as soon as one is made illegal, they pop out the next one. And that one's made illegal, they'll pop out the next one. And so this has been a real problem for the DEA. It's a problem for toxicology labs, because how do you keep up trying to identify all these different compounds and their metabolites and the pyrolysis products? When you smoke this stuff, you get breakdown of these different compounds. So it's been a real mess. And that last one there, metragenine. This is illegal in some countries, but it is it's a root from a plant that people will take to get the similar effects of opiates. Illegal in Thailand, still legal here in the United States. Okay, so tox specimens. I need to move a little faster here. Typically, in post-mortem toxicology, we can take the liver, we can take blood from the femoral artery, we can take, I told you about the vitreous humor, but we do not want to take heart blood. Heart blood is the easiest blood to be contaminated by vomiting, by trauma. Where we typically go in post-mortem toxicology is the arteries in the legs, which are so far away from the stomach, less likely to be contaminated. But toxicology these days, the compliance toxicology uses urine, cuts hair. We're doing oral swabs now, segregation of compounds in all of these matrices. So what happens when you take a drug? Well, it's absorbed into the bloodstream, and the bloodstream will distribute this all around the body. This is what we look at when we're talking about pharmacokinetics. We have metabolism taking place. The body sees it as a foreign invader. So it's going to do what it can to change the shape of that invader to get it out of the body and excrete it. So just quickly, this is a time course, if you will, of where the drug is in the body. We've got it flowing through our blood, absorption and elimination or excretion. Metabolism starts that process. But as you can see here, in terms of time, it gets out of the blood pretty quickly. Okay? Well, I shouldn't say, it depends on the drug. But when you compare blood to urine, urine is always going to have a longer detection window, which is why it makes it a good sample for toxicology. Now, in terms of technology and being able to identify drugs, the technology keeps getting better and better. And as it gets better, as our limit of detection drops, the amount of time that we can detect a drug after someone takes it gets longer and longer and longer. So generally speaking, a toxicology lab will screen first and confirm second, okay? Kind of like the cups. We don't want to just make a judgment on the cups because there are problems with the cups. They're not specific enough to fire somebody or not specific enough to send somebody to jail. So the two methods of analysis we have are immunoassay. This is recognizing drug groups with the use of an antibody. We inject poor little rabbits with heroin, and the little rabbits develop an antibody to recognize heroin or opiates. They take that poor rabbit and bleed it and take the antibody and then mass produce it. And now we've got something that can recognize opiates in an antigen-antibody reaction. It's awesome. We can identify all kinds of things with this type of technology. In fact, even going into sperm identification in sexual assault cases, they've made antibodies to recognize certain proteins found in seminal fluid. They've made proteins to recognize species, where you can inject deer blood. You got blood on the front of your car. Is that human blood or deer blood? Well, you may need to know that if you're trying to solve a hit and run. So if you inject a rabbit with deer blood, the rabbit's going to make antibodies to recognize deer blood. You take that antibody out, and now you have the ability to determine exactly what species is on the front of that car. Let me not get off topic. Immunoassays are very powerful in getting us to the right place where we can then confirm. So now, physicists, I've got 7 minutes to talk about some of this cool stuff. This is the confirmation instrument that we use here in Longview, and this is the new gold standard, if you will, for confirming drugs and actually identifying lots and lots of compounds. This is used in protein chemistry. It's used in analysis of steroids. I mean, anything that you can get into solution can be analyzed with it conclusively with this instrumentation. So, if you haven't taken analytical chemistry, but maybe you've seen one of these around somewhere. Anybody seen one of these? Yeah, the petroleum industry uses a lot of these. This is essentially an ability to separate petrochemicals into the things like octane and decane and decide, be able to pull out and separate these different compounds. So we do the same thing in toxicology, where you might start with urine and try to separate out all the different compounds so we can identify them one by one. So this is our column. So if the petroleum industry is using this to separate out the different components, we're using this. And essentially what you have on the inside are little molecular arms. And as we pass molecules of drugs through, depending on their shape, these molecular arms are going to slow some drugs down and let other drugs pass through quickly. Methamphetamine is a very small drug. Boom, it's going to fly right through that column. But cholesterol or a steroid is huge, like a cow going through a scrub brush field is going to get slowed down. And so that's how we physically separate compounds. Y'all heard of this before? Chromatography? Okay, good. Well, this is just a schematic showing where we have a mobile phase and a stationary phase, and its preference, the compound's preference for the moving part or the stationary part allows us to physically separate these compounds. So with the liquid chromatography tandem mass spectrometer, essentially what we have on this side is that separation part where the column is separating out what started as a group of A, B, C, and D is now allowed to come out of that column at different times, and that is key because as each one comes out, we're going to then fragment it into pieces. And we're going to monitor for certain fragments. And these fragments are going to tell us what drug is present because all compounds break apart a different way. Okay? And if we can find out how they're breaking apart, we can then identify what compound it is. So maybe this is the meat slide for you physicists. This is one of the things I love about toxicology is there's a lot of cool things going on. But essentially, this is the tandem mass spectrometer. The source, you make your injection of diluted urine. It goes into a source which evaporates the solvent. The drugs are left to be swept into, that's what ESI stands for, electrospray ionization. Gets swept into octopole number 1, which is a focusing lens, which is going to get these different unexploded molecules going in a path. Okay? Once they enter the next spectrometer, if you will, we're going to have it selecting mass. So let's say we're interested in cocaine, which has a mass of 303. So we're going to separate out that cocaine molecule and let it go into what we call the collision cell. And using nitrogen, ultra-pure nitrogen, we can then do a gentle fragmentation of the drug to get, a gentle fragmentation of the drug to get these characteristic pieces. And that's what they are, characteristic pieces. Keeping this beam going, we then get into the last quad, which essentially identifies, assigns a weight, a mass over charge per fragment. So that last quadrupole allows us to identify essentially the kinetic, but through kinetic energy hitting the detector as to what size fragment it is. So when we're identifying different drugs, and these are all the drugs that we identify in one injection. And it's not just identification. Our method here in Longview also has a 9-point calibration curve. So not only out of one injection could we quantitate or identify all these drugs, but we can also quantitate all of these drugs off of one injection. Now, this is what we call dynamic MRM, which is multiple reaction monitoring, is what that stands for. But there's some new things that you guys are going to design that's going to allow us to see even more compounds. Where instead of having the detector looking for all these compounds at the same time, on the front end we might have a detector that says, you know what, this one's not present, this one's not present, so we can give it more time to look for the ones that are present. So physics is definitely going to design even better tandem mass spectrometers in the future. But as I said, some of these are also metabolites. We allows us to identify compounds that are not just, that could be adulterated. So in conclusion, prescription drug abuse is a problem. Prescribing of opiates too often is a problem. Yes?
Sorry, I'm about one slide late here, but could you describe, or maybe you did, what the tandem refers to?
Yeah, well, side by side. So you have...
Sort of a standard and a control and something else?
No, like literally, like if you do like a tandem parachute jump, you got somebody attached to the front of you, you're side by side. So tandem here in this case just means one after another after another. Like, yeah, whereas like GCMS is just one quadrupole, tandem mass spectrometry would be several of these quadrupoles. Although the Agilent instrument has a really interesting octupole on the front end, which makes them special in terms of other manufacturers out there.
Thank you.
You bet. Other good questions, because we are kind of at the question period here. So compliance monitoring is a tool, keeps doctors out of trouble, allows us you know, protect taxpayer money if you're getting a drug subsidy. A lot of good reasons to have this. LCMS technology is going to be the new gold standard. It had been GCMS, but you're limited with GCMS into what you can volatilize into air at high temperatures. LCMS takes place at like very low to room temperature. Okay, it's also good for explosives analysis because you don't want to break apart compounds in a GCMS. You're going to blow up your GCMS. Well, not really. It's just be a small amount, but not stable in that source. So the LCMS source is good for inks, anything soluble in solution. So the Secret Service, when they're analyzing inks, uses a lot of LCMS technology. So a lot of forensic science is going this way. It just so happens that right now, this is where most of the instruments are being purchased, both in explosives analysis and compliance testing. Let's see here. So yes, results improve treatment plans. And one thing, the reason why I love going to work, out of all the different forensic disciplines I could have chosen, I thank God for the one that I have because, one, it's got a private industry direction to go, which is where the money's at. And two, there's so many unanswered questions. Even genetically, we are all metabolizing drugs at different rates. Some of us in this room will metabolize drugs in a dangerous rate, where, for example, you may intend on getting codeine to convert to morphine, but what if you're an ultra-high metabolizer? When they're prescribing drugs, they're figuring you're just a normal metabolizer. But if you have a genetic defect that makes you an ultra-fast metabolizer and they're out there, boom, you can die because morphine gets it, too much morphine in your system too fast. You're out there on the edge of the population curve. Okay, so I've got time for questions. Yes?
I guess it's probably not a popular drug to use then, but I didn't see like LSD or lysergic acid up there at all.
It's a good point. That's right. What people are taking today that they think is LSD has turned out to be some of these N-bombs. What you thought bath salts were dangerous, N-bombs are killing people left and right because it looks like a bath salt, but it's 20 times more potent than a bath salt. So the kids I say kids, people are like snorting what they would normally take as a bath salt, and it kills them. So yes, a lot of what people are buying these days thinking is LSD is actually an N-bomb, but in the big picture, we don't see LSD as often as these other compounds. Yeah. Yes?
It probably depends on the compound that you're looking at, but what is the range on your 9-point curve?
Okay, very good. It does depend. Because fentanyl, you wear these little patches. When people abuse them, they suck on them. We've even had people who've taken them off nursing home patients and then suck on them. That's disgusting. But they're meant to absorb through the skin in very small concentrations. So for like fentanyl, our low end would be like 1.5 nanograms per mil, and our high end might be 200 nanograms per mil. But then on the opiate side, you've got like a low of 25 nanograms and a high of 4,000 nanograms per mil, and it could probably go way much higher than that. But then you start losing the linearity of your curve. Good question. Yes?
And so you test for workplace drugs in the employees then, and so you wouldn't test then for, you don't see any of the type of drugs then that would be used for terrorism or anything like that, then it's just strictly...
Right. Most of what we do is testing for doctors' offices to show that they have compliance with their patients. We do have a client that is a hospital, and we get some interesting cases where nurses are kind of pilfering, stuff out of the narcotics cabinet. But in terms of the stuff that you would see in a terrorism event, liquid chromatography, mass spectrometry would be very important to do those kinds of identifications. But you're talking about very specialized personnel who can handle that type of stuff. Texas has such a lab, okay, in Austin, where if they're called to do it, they're there. In fact, there's little regional centers all across the United States that are set up to do exactly that. And they're using LCMS technology.
great. So,
Yeah.
a lot of states now have legalized the use of marijuana for both medical and recreational use. In your industry, how have you seen that unfolding? Is it better or worse, or do you have any feel for that, being in that sort of drug compliance type industry?
Well, yeah, I don't know how they're going to handle compliant, making sure you're compliant with your marijuana. They're usually the doctors who are prescribing it for pain. We do have a client in Oregon. It's done under the tongue with a tincture, okay? So it's not so much smoking, but do you berate your patient for not taking their marijuana tincture? I don't know. What I do know is probably the growth industry is going to happen in terms of testing how much THC is present in these different strains, both from a regulatory standpoint and maybe both from a growing and genetic standpoint. I see that as a growth industry. I know somebody who worked for one of the manufacturers. Restec is a column producer here in the United States, and I know that person went to Denver to do just that, identify the quantities that are in different strains of marijuana.
Okay, so there you go.
Yeah.
Your job, careers.
It's going to be growth industry, yes.
We'll continue our discussion over at lunch. We'll be in the Joyce Room. So if you want to join us for lunch in the Joyce Room in the Corner Cafe, please do. And let's thank our guests.
Well, and let me also say we are hiring. So if you, here's my sources. If you are interested, that's a GJELLICK. So look us up. We're hiring chemistry and biology and biochemistry majors.
Or join us for lunch.
Or join us for lunch.
See you all in 2 weeks in East Hardwood, 101. Thank you. There's some that came down over there.
Wow, I was floating.